This is part of our video series on human-centered evaluations for NLP explanations. Check out the link for more resources. You're currently here.
Now that you've seen some detailed examples of human-centered evaluation, let's discuss some high-level challenges and considerations to keep in mind as you design your own evaluations. So an important challenge in experimental design relates to measurement, reliability, and validity. This tells us how much we can trust our results. Think of our experiment as an archer trying to hit a target both reliably and accurately. And just a note that while I will discuss these concepts briefly, this is a very complicated subject. In fact, entire tutorials have been dedicated just to measuring. So for much more detail on this topic, please refer to the Meaning and Measurement of Bias tutorial, for which I've included a link here and on the following slides. So first, consider reliability, or whether the measured effect is repeatable. If we ran the experiment again with different participants, would we see the same results? We hope that using large enough participant samples and giving clear task instructions will yield reliable experiments. But reliability alone is not enough. So without validity, reliable measurements will just consistently give the wrong result. Measurement validity gets a little trickier. It refers to whether an instrument is right in that it measures what it's intended to measure. And we consider two types of validity, internal and external. Internal validity describes how valid is the claim made by the experiment, or whether the independent variables we varied actually cause the observed differences. A primary concern regarding internal validity is that the observed changes might actually be due to group differences or uncontrolled variables known as confounds. So for example, imagine a task where participants read news articles and interact with the text summarization system with or without explanation. If not controlled for, participants' reading speed is a confound that would surely affect measured efficiency. We also consider external validity, how well findings can generalize. Threats to external validity include that the participants might not be a representative sample. For example, participants recruited from college mailing lists might not be representative of a more general population. Another issue is that the study environment might not map to real-world contexts. And in fact, a major challenge with evaluations is the unrealistic nature of many experimental tasks. So let's discuss unrealistic experiments a bit more. For one, many experiments use proxy or otherwise simplified tasks which don't match well with real settings. As we discussed previously, proxy tasks like simulation can be misleading and don't necessarily match actual decision-making tasks. Further, unrealistic simplified scenarios like binary image classification tasks or counting jelly beans might not generalize well to other decision-making tasks. Also, typically experimental task length is quite short, which might mean there's not enough time for a user to really get experience with the system and test true interaction or perceptions. Finally, we need to think critically about participants, including their expertise and level of engagement. So while recruiting from crowdworking sites is desired when we need to get lots of participants on a limited budget, domain-specific tasks such as legal or medical should really be tested with users with knowledge of that domain. And also consider users' level of engagement or their personal connection with a task. In many cases, we explore explanations as a promising solution for high-stakes scenarios where user risk is involved. But how can we realistically manipulate risk with crowd workers? Simply giving them a high-risk task like recidivism or loan application is not sufficient unless participants have some skin in the game. We also need to ensure participants are motivated, that they try their best at the task for the results to be valid. Promising bonuses for high-quality work is one approach. And speaking of bonuses, I want to touch quickly on pay rates. It's important to ensure ethical pay rates for human subjects experiments. You should aim to pay at or above minimum wage, which you can determine based on estimated task length. And when paying bonuses to motivate participants, all participants should receive the bonus. So it might feel a little hopeless given all of these experimental challenges. So what can you do to be successful? First, just recognizing and documenting these pitfalls is important. For example, when writing up your study results, Be sure to discuss limitations of your experiment and where or where not your results would generalize. You should also aim for a large enough sample size and the right participants, those with necessary domain expertise and buy-in for the experimental task. You should write clear and concise instructions for your task and include a tutorial or practice trials. This will ensure all participants can complete the task effectively and without uncertainty. Always remember that experimental task design is not meant to be quick or easy. You need to give yourself time to iterate on your plan and discuss with others before finalizing. And even with that, you need to pilot. This means run practice sessions of your experiment before kicking it off. First internally with friends or colleagues to check that the instructions make sense, then on the platform where you'll conduct the experiment to ensure you're recording all data as expected. Finally, human-centered AI evaluations are interdisciplinary in nature, so when possible, ensure you're collaborating with other fields such as AI, HCI, psychology. We hope that this section of the tutorial has given you an understanding of the value of application-grounded evaluation with human subjects and the background to conduct your own experiments.
This video isn't the end. You're currently here. If you're lost, click on the link below for source code, slides, and other resources.